Welcome guys to the series of paper 2 2023 GCE question 2a and 2b solved. Now question 2a Roman numeral question 2a reads, in a geometric progression the second term is 21 and the fourth term is 189. Calculate the first term and the common ratio. Looking at the terms the way they are, we cannot manage to find the common ratio direct to say dividing term T2 by T1. Why these terms are not consecutive, they are not following each other, there is a space, there are other numbers in between. So what we are going to use instead of direct method, we are going to be forming equations. So we'll form an equation using the formula for nth term. Okay, so this is the formula for nth term, Tn equals to A r to the power n minus 1. So we're going to form an equation for this first term, we'll form an equation for this fourth term. So this is the second term and this is the fourth. Okay, so T2 is equal to 21 and T4 is equal to 189. Okay, so on each of these there is a position given. So 21 has been given to say it is on position 2, second means 2, so n equals to 2. And then 189 is on position 4, so n equals to 4. Using this, let us form now an equation for the second term. So we're going to have 21, so where there is Tn here, where there is Tn, we are going to substitute with the number 21. So 21 equals to A we don't have, the first term represents first term, okay, multiplied by r we don't have, but n here on the power we have, it's a 2. So we'll have r equals to 2 minus 1, where we're going to have the final answer as 21 equals to ar. So this is our first equation. Our second equation, we'll use the fourth term, same procedure. So where there is T4, we'll substitute with the number 189. So we'll have 189 equals to A times R. And then on the power there, this time around the position is 4. So we'll have R equals to, to the power 4 minus 1. When we subtract there, we're going to have 189 equals to A R to the power 3. This is our equation 2. Let us hop on the other side where there is enough space. So next now we're going to divide equation 2 by equation 1. Okay, so equation 2 is 189 equals to A r to the power 3 divided by 21 equals to A r. Okay, numbers on their own, letters on their own. So here a 21 can go into 189. Do you know how many times? Good, it goes there 9 times. Okay, and then A dividing into A, this will give us 1, and then r dividing into r to the power 3, this will just give us r to the power 2. Okay, so the final will be 9 equals to r to the power 2. Here we introduce the square root on both sides, so the final answer will be r equals to 3. Okay, now this is just the common ratio. The question is asking us to find both the common ratio and the first term. So we'll pick one equation, either the first or the second, but I'll go with the first one because we'll beat on time, it's much simpler. So the first equation is written like so, then times, where there's r here, we'll substitute with what we found, which is a 3. So times 3 and then divided by 3 on both sides. So 3 into 3, it goes there 1 time. So 1 times A, we're going to have A, and then 3 can go into 21, good, 9 times. So A equals to 9. So now we have solved the first question. We are saying R is equal to 3 and A is equal to 9. Okay, we go to the next one where we're finding the 60th term. Okay, so calculate the 60th term. We are still using the nth term. So we want to know what number is on position 6. That is what the question is asking. So knowing the position number, this is the formula that we are using. Okay, we're not changing. So Tn equals to A r to the power n minus 1. Now this time around it is T6. So we don't know the number which is on position 6, but we know the position. Okay. Next is So the position is a 6, so n equals to 6. So T6 equals to, now A we found it was a 9, and then R we found it's a 3. So 9 times 3 to the power, where there's n here, okay, we substitute with the position which is 6, so 6 minus 1. Okay, so we're going to have 9 times 3 to the power 5. Okay, so here when we multiply or when we expand the 3 to the power 5, we're going to have 243. Okay, so multiply 243 times 9. What are you going to have? Perfect. We are having T6 as 2187. So the number which is on position 6 is 2187. Good. We go to question A, Roman numeral 3. Calculate the sum of the first 5 terms of the progression. Now, on the sum, we have two formulas. We have a formula where R is less than 1, and we have a formula where R is greater than 1. Okay, so if you look at the value for R here, our common ratio, this is greater than 1. So the formula we can use is this formula here. So this one here requires us to use it when R is greater than 1. Okay, so Sn, the n represents the sum of the numbers that you are adding. So we are adding the first 5 numbers. So where there's n here, we're going to substitute with a 5. So S5 equals to, we don't know the sum. Of course, we substitute. The A is a 9 times R is a 3. Then the sum we're finding is a 5. So this n represents 5. So 5 minus 1 over 3 minus 1, which is this setup here. Let us expand what is in the brackets. So 3 to the power 5 is 243 minus 1 divided by 3 minus 1 is equal to 2. Okay, the next 9 times 242, when you subtract 243 minus 1, we are going to get 242. Okay, so 9 times 242, what is the answer? Good, 2178. Divide this number by a 2. It means we get our sum of the first 5 terms. So the final answer will be 1089. So that is the sum of the first 5 terms. Okay, we proceed to question number 2b, which is a matrix. Okay, so we have matrix P equals to 7x, negative 2, negative x, then 1. So this is a 2 by 2 matrix. And then the question is saying, find the value of x for which the determinant of P is negative 10. So here, so long as they've mentioned the word determinant here, it means they're requiring us to use the formula for determinant. And normally determinant is we multiply the values that are in the major diagonal. So 7x and 1, they are in the major diagonal. So the product of the major diagonal minus the product of the minor. Okay, so product of the major is 7x times 1. Okay, product of the minor diagonal is negative 2 times negative x. So we are subtracting the major minus the minor. Okay, this should be equal to negative 10. That is our determinant given. Okay, so 7x times 1 is 7x minus negative 2 times negative x will give us a positive value, which is 2x. So we have minus 2x equals to negative 10. Okay, 7x minus 2x gives us, good, 5x equals to negative 10. So divide on both sides with a 5. So 5 into 5 will give us a 1. So 1 times x will give us x. 5 will go into negative 10 because they are 2 times. So x equals to negative 2. Okay, now having found the value for x, we are going to rewrite our new matrix now, substituting where there is x. So if we put a negative 2 where there is x here, we have 7 times negative 2, where we'll get negative 14. Then here, the negative and the negative will give us a positive value. So here we'll have a positive 2. So our new matrix now will be negative 14, negative 2, 2, and a 1. Okay. The next question says, hence find the inverse of P. Okay. So finding the inverse of P, we are going to first of all write down the adjoint matrix. So adjoint matrix, if you can see, there's some slight difference with this one and this one here. So the adjoint matrix, we are going to interchange the values that are in the major diagonal, interchanging their position. So here where there is a 1 will go where there is 14, and the 14 will come, the negative 14 will come where there is 1. This is what you are seeing here. Okay, so we have interchanged 1 and the negative 14. Then these numbers that are in the minor diagonal, we multiply them with a negative 1. Okay, so if we multiply 2 times negative 1, we are having negative 2. If we multiply negative 2 times negative 1, we are having positive 1. Okay, this will be multiplied by the inverse of our determinant. So inverse of the determinant, we take it over 1. So inverse, we swap, the 1 goes up, the 10 comes down. So it becomes negative 1 over 10. Okay, this is a scalar. It has to be multiplied to each and every element inside this matrix. Okay, so when we multiply negative 1 over 10, we're going to have something like this. Okay, so as you can see, those values over there. Okay, so next we will multiply, so negative 1 times 1, that will be negative 1 over 10. Then negative 1 times 2, that will be negative 2 over 10. Negative 1 times negative 2, it will be positive 2 over 10. Negative 1 times negative 14, it will be 14 over 10. Some of these fractions can be reduced. So here we can reduce with a 2. We have a 1, a 2 into this, we have a 5. Okay, same applies here, 2 into 2, 1, a 2 into 10, that is a 5, a 2 into 14, that is 7, a 2 into 10, 5, so we have 7 over 5. This becomes our inverse for matrix P. Okay, thank you very much. Keep on watching the series for paper 2 2023 GCE.